How are teleconnections between Antarctic and Southern Ocean weather systems studied? If you're curious about how scientists understand the connections between the weather systems of Antarctica and the Southern Ocean, you're about to uncover some fascinating methods. To study these teleconnections, scientists use a combination of models, observations, and historical data. Let's start with models. Researchers employ something called slab ocean models and coupled atmosphere-ocean general circulation models, GCMs. In a slab ocean model, the ocean is simplified to a mixed layer with a uniform depth, which helps isolate atmospheric teleconnection pathways from oceanic ones. For example, the Community Atmospheric Model version 4, CM4, is used with a mixed layer depth of 50 meters to simulate how changes in tropical Pacific sea surface temperatures, SSTs, affect the Southern Ocean SSTs. These models are run with different scenarios, such as imposing anomalous heat fluxes in specific regions to see how the system responds. This helps in understanding the dynamic feedback through atmospheric circulation between the Southern Ocean and the tropical Pacific. Observational data also play a crucial role. Scientists analyze satellite-derived sea surface temperatures, SSTs, to identify correlations between the tropics and the Southern Ocean. For instance, studies have shown significant spatial correlations between SSTs in the tropics and those in the Southern Ocean, particularly during events like El Niño Southern Oscillation, ENSO. Historical climate data are another key component. Researchers look at long-term trends and patterns, such as the changes in sea ice extent, ocean heat content, and ice sheet thinning over the past few decades. These changes are often linked to tropical teleconnections, such as ENSO, the Interdecadal Pacific Oscillation, IPO, and the Atlantic Multidecadal Oscillation, AMO. The Southern Annular Mode, SAM, is also an important factor. SAM influences the westerly winds and storm patterns over the Southern Ocean, which in turn affect sea ice formation and retreat. For example, a positive SAM phase brings unsettled conditions to the Antarctic coast, leading to increased sea ice production, while a negative SAM phase results in more settled conditions and reduced sea ice. To synthesize all this information, scientists compile comprehensive reviews and studies. These reviews help in understanding the physical mechanisms behind these teleconnections and their long-term climatic impacts. For instance, a study by Lai et al. Summarized the current state of understanding about tropical teleconnections to Antarctica and the Southern Ocean, highlighting the role of Rossby wave dynamics and the need for sustained long-term observations and more realistic climate models. In summary, studying teleconnections between Antarctic and Southern Ocean weather systems involves a multifaceted approach using models, observational data, and historical climate records. By combining these methods, scientists can better understand and predict the complex interactions between these distant regions.